Good morning, good afternoon, and good evening to you. Based on the period of time you are following up in our class today, I am Ismat. In today's class, I'll be introducing a course called, okay, let me draw my line. So I'm just going to be very fast here so as not to waste your time. Okay, I'll be introducing a course called Physics 201, which happens to be modern physics. Thank you. So now this course is all about okay, I'm going to start from the known to the unknown like we normally know. First thing foremost, if today happens to be your first day of seeing or watching my video on YouTube here, do well to click on the subscription button and subscribe. It's free. And as well, click on the notification button so that whenever I release my video, you'll be the first person that will be seeing it. Please, this video is, whenever I draw video, I will indicate whether it is for JAM students or it is for university students. For this particular one, this is for university students, please. Thank you. So let us move ahead without wasting much of our time. First thing first is to know the course that we are about taking, I'm about teaching you, which is modern physics. In this modern physics, we start from a well-known course called classical physics, which is Newtonian physics as well. That's the olden physics. Let me use that word, the olden physics. Classical physics. Now, classical physics, let me baptize it with a name called Newtonian physics. Newtonian physics. And let me also baptize it with a name called Galilean, where you will see Galilean transformation. Where you see what? Galilean transformation. So, from there, I will be looking into, though I will be telling you the differences between classical physics and modern physics. Classical physics is just the olden physics. Are you there? So it talks about the motion, but in this course particularly, we are not going to be telling you about motion, some other things that you know about classical physics, but we are going to base on the things that you have to know that will help you in your test and your exam. Now, in Newtonian physics, which is also the classical physics that we are talking about, there I'll just be very fast and very concise so that you get what you need. I'm not trying to make notes, I'm just trying to give you what you need to pass your test and your exam. First thing first, in Newtonian physics, where you talk about, let me write down the things that you need to know. Time, space, which we also called length. Are you there? Length. And we also have another thing called speed of light. Are you there? Speed of light. Now, speed of light is denoted using c. Are you there? So it is denoted by using what? C. So now, in this Newtonian physics, where you talk about, now in this Newtonian physics, you see that time is what? Invariant. The man called Galilei Galilean say that what time is what invariant. Are you there? Now when you say that time is invariant, what do I mean? Time is invariant means time does not what change. Are you there? Time does not what change. Time remains unchanged. Are you there? That's time remains absolute. Are you there? So you can see what I mean, that time is invariant means time is the same. That's it does not change. So another thing I've said about time, for Galilean transformation, for Galilean physics, for Newtonian physics, time is what? Time is invariant. Please don't forget. Time is what? Invariant. Then for space, that is length. Space, that is length. Length is also what? Invariant. Is also what? Invariant. Are you there? Length is also what? Invariant. It does not change. Are you there? It does not change. Then for speed of light, speed of light, please pay attention. This will be your question that you face in your exam. Are you there? The questions that you will see, the little question that you will see in your test and your exam. So for speed of light, which is c, remains constant. Is not constant, please. Is not what? Constant. Speed of light is not constant. Are you there? Speed of light is not what? Constant. Are you there? So these are the three things that you have to note concerning what? Concerning Newtonian physics. That's the classical physics that we are talking about. Now from there, now I will be jumping into the Einstein physics. The Einstein physics. So now for Einstein mechanics, remember that I told you that this Einstein, okay, I've not said it. Einstein, the Einstein mechanics, there where you'll be looking at the Lorentz transformation. But for Newtonian mechanics, you'll be looking at what? Galilean transformation. Please don't forget that in classical, okay, let me just write it down. In classical physics, you'll be looking at the transformation called the Galilean. Please don't mind my handwriting. If you're not seeing it, just use the word that I'm saying. I'm just being fast. The Galilean transformation. Then for I said for classical physics, where we'll be looking at Galilean transformation, right? Then for what do we call it? The Einstein physics. That's the Einstein physics. You'll be looking at the Lorentz transformation. Are you there? So remember that these two persons, Newton, this classical physics is also called Newtonian physics. Newtonian physics. Are you there? So now, this classical physics, and okay, let me just write classical physics and the Einstein. Are you there? So the Einstein, where you'll be looking at the Lorentz transformation. Are you there? Lorentz transformation. LOT, I will be using LOT. That's LO. Whenever I say Lorentz transformation, it means whenever I say LOT, whenever I write LOT, please know that I mean Lorentz transformation. Are you there? So Galilean transformation is from classical physics, while Lorentz transformation is from the Einstein physics. Are you there? So that is what we want to give out today. Now for this Einstein physics, that is Lorentz transformation, there you have to know that time is variant. That's time changes in Einstein physics. But remember that that of classical physics, we say that time is what? Invariant. We say that time is what? Invariant. But here For Einstein physics, we say that time is what? Variant. What's the meaning? What's the difference between variant and invariant? Variance is, something when you say varies, that's it changes. So the word variant, so something that is variant, that's it changes. But something that is invariant, it does not what? Change. Are you there? So that is for Einstein mechanism. Then for speed, the speed of light is constant. The speed of light is constant. Are you there? Then for space is also what? Variant. Space changes. This man Einstein looks like, the man looks a lot of things, and after the Lorentz transformation and all the rest, he observed that the time that you are, when as time goes on, you get to understand this, and when we start solving things, you get to understand what more better. Are you there? So notwithstanding, not wasting of much of our time, let's start with some equations that will help you understand this thing more better. Thank you. Okay, you are welcome back again. Now I will be drawing some things, and I will be writing the Galilean transformation and the inverse Galilean transformation. Now here is, let me just draw something. Let me just draw something. Sorry, that's the x and y coordinate that we know now. So this is y, this is x, and this is z. Are you there? So for this is the Galilean transformation. The one that is moving, this one is the one that is not moving. You can denote it with x with no prime. There is no prime here. Then this one, you can as well draw another thing. You can as well draw another thing. This is x, y, and z. Now this one has h prime. This is prime, please. This is prime. So it has h prime up here. So this h prime, for this thing, this one will also have prime. Now what does it mean? That this one is what? The one moving. The one that has prime is what? Moving. Why this one that doesn't have prime is what? Stationary. Are you there? Now I will be bringing out equation of Galilean transformation, and as well I will also write the inverse Galilean transformation. Are you there? So now for this one, let me start with this one. For this one, it is x prime equal to x minus vt, and the y prime equal to y, z equal to what? Z prime, and the t equal to t prime. This is equation what? 1. Equation what? 1. And this is the Galilean, this equation 1 is the Galilean transformation. Are you there? Why the one that has, we have x, so we have x equal to s prime plus. Now look at something. Well, let me just write it first. Vt, y equal to y prime, and the z equal to z prime, then t equal to t prime. This is what? Equation 2. Now please, between these two equations, this and this, can you see a difference? Do you see a difference there? Look very well. Just watch very well. Do you see any difference there? Please, let's just watch very well. Now the difference there is that one, this one starts with prime, but that is not the major difference. Now the major difference, now this one is the Galilean GT. Are you there? Why this one is the what? Inverse GT. What is GT? Galilean transformation, right? Now this one that has S prime. Now when you look at it, the Galilean transformation has minus here, while the inverse Galilean transformation has what? Positive, that's plus. So the thing that differentiates the inverse and the inverse Galilean transformation and the main Galilean transformation is the word sign. Are you there? Is the word sign. That's the main thing. So, and remember, you'll be asked to state the difference between the Galilean transformation and the inverse Galilean transformation. Right. Let us now solve some problems.